The sound is hypnotizing. Thousands of tiny metal spheres roll simultaneously through transparent tubes, creating a musical cascade that echoes through the factory like steel rain. Each sphere, smaller than a pinhead, will become the beating heart of a pen that can write for 2 kilometers before running dry. In a single production line, 50,000 pens are born every hour, one every 0.07 seconds. Robots work in perfect synchrony, assembling microscopic components with surgical precision, while computer vision systems inspect each product at speeds that defy human perception. But here's the fascinating paradox. How can something as simple as a ballpoint pen, an object that costs pennies and is considered disposable, require one of the most sophisticated manufacturing technologies on the planet? How does a factory manage to produce 20 billion pens annually, each one working perfectly, without a single human hand touching the process? The answer is hidden in the depths of automated factories that operate like living organisms, where every movement is calculated, every component is perfect, and every second counts. Prepare to discover how precision engineering transforms basic raw materials into the most popular writing instrument in human history, a process where the simplicity of the final product conceals extraordinary technological complexity. The history of the ballpoint pen began with frustration. In 1938, Hungarian journalist Laszlo Biro was tired of smudging ink with fountain pens and observed that newspaper printing ink dried quickly without smearing. His genius was imagining a tiny sphere that would roll over paper, distributing viscous ink uniformly. The first prototype was rudimentary, a steel sphere in a simple tube, but revolutionary. During World War II, RAF pilots discovered that these pens worked at high altitudes, where fountain pens failed due to atmospheric pressure. Suddenly, the biro became essential military equipment. The true revolution came in 1950, when Frenchman Marcel Bich, who simplified his name to Bic, applied mass production principles to pen manufacturing. His vision was audacious: create a pen so cheap it could be disposable, but so reliable it would never fail. Bich invested in Swiss precision machines, adapting technologies from the watchmaking industry to produce microscopic components on an industrial scale. The first automated factory could produce 1,000 pens per hour, a number that seemed impossible at the time. The 1960s marked the birth of modern automation. Pneumatic systems replaced human hands, numerical control ensured absolute precision, and robotized assembly lines enabled 24-hour production. What began as a simple idea evolved into one of the world's most automated industries. Today, modern factories produce pens at speeds Bich never imagined, using technologies that seemed like science fiction just decades ago. The ballpoint pen became not just a writing instrument, but a symbol of automated manufacturing perfection. The journey of a ballpoint pen begins long before final assembly, in the depths of extrusion furnaces operating at 200 degrees C. Polypropylene granules are melted and molded into perfect tubes through precision dies, each calibrated to produce diameters with 0.01 mm tolerance. Controlled cooling systems solidify plastic at calculated speeds to avoid internal tensions. Infrared sensors continuously monitor temperature, adjusting the process in real time to ensure each tube has the exact strength needed to withstand writing pressure without breaking. Ball tip production is where the magic truly happens. Tungsten spheres, each weighing only 0.005 grams, are polished until achieving perfect sphericity, deviations smaller than 0.005 millimeters. Specialized machines create microscopic conical seats where these spheres will fit with absolute precision. Assembly robots work at superhuman speed, inserting spheres into metal tips through pneumatic systems that apply exact pressure. Each tip is individually tested by computer vision systems that detect defects invisible to the human eye in fractions of a second. Ink formulation happens in automated reactors that mix dyes, solvents, and additives in precise molecular proportions. Viscosity is continuously monitored. Too liquid and the ink leaks, too thick and it doesn't flow. The ideal point allows ink to flow smoothly through the sphere without drying in the tube. Automated filling systems inject exactly 2.3 grams of ink into each refill, using precision nozzles that avoid air bubbles. Each tube is hermetically sealed to ensure ink remains fresh for years before first use. At the heart of modern pen factories are integrated manufacturing systems that operate like giant electronic brains. PLCs, programmable logic controllers, coordinate thousands of simultaneous operations, from furnace temperature control to the rotation speed of each motor. Advanced computer vision represents the most impressive technological frontier. High-resolution cameras capture 500 images per second, analyzing each component through artificial intelligence algorithms. Deep learning systems identify microscopic defects that would escape human inspection, automatically rejecting imperfect products. 6-axis collaborative robots execute movements with 0.02 mm precision, assembling components in choreographed sequences. Force sensors detect anomalous resistance during assembly, stopping instantly if something is wrong. Each robot can perform 15 different operations, automatically adapting to product variations. Total traceability systems use microscopic laser-engraved codes on each component. Industrial blockchain records every production step, allowing any pen to be traced back to its original raw material. If a defect is detected, specific batches can be identified and isolated within minutes. Predictive artificial intelligence analyzes production patterns to predict equipment failures before they happen. Machine learning algorithms continuously optimize production parameters, increasing efficiency and reducing waste. The system learns from each batch produced, becoming smarter every day. Autonomous maintenance uses drones equipped with sensors to inspect equipment in hard-to-reach areas. Specialized robots perform lubrication and minor adjustments without stopping production, keeping lines operating 24/7 at maximum efficiency. The obsession with perfection in pen manufacturing borders on scientific fanaticism. Each pen produced must pass 32 different quality tests before leaving the factory, from microscopic dimensional checks to writing tests that simulate years of use in minutes. Mass spectrometers analyze ink chemical composition in real time, detecting variations of less than 0.01% in pigment concentration. This precision ensures every blue pen has exactly the same shade, regardless of when it was produced. Automated flow tests make each pen write for 100 meters on robotic machines, checking line consistency, color intensity, and absence of failures. High-resolution cameras analyze every stroke, detecting microscopic variations in writing quality. Controlled pressure systems test each tube's resistance by applying force equivalent to being stepped on by an adult. Ultrasonic sensors detect internal microfractures that could cause future leaks. Only tubes passing all tests proceed to final assembly. Accelerated aging laboratories subject samples to extreme conditions, temperatures from 40 degrees to plus 170 degrees, 95% humidity, intense UV exposure, simulating decades of use in weeks. Vibration tests replicate global transport stress, ensuring pens arrive perfect to the final consumer. Statistical process control continuously monitors every production parameter. Algorithms detect trends before they become problems, automatically adjusting machines to maintain constant quality. Zero defects isn't just a goal, it's an operational standard. The ballpoint pen industry is undergoing a silent green revolution. Biodegradable plastics derived from cornstarch and sugarcane are beginning to replace traditional polypropylene, maintaining durability while reducing environmental impact by 60%. Closed-loop systems recycle 98% of water used in cooling and cleaning processes. Advanced filters remove microscopic contaminants, allowing infinite reuse of the same water. Water consumption per pen has been reduced from 50 ml to just 2 ml in a decade. Renewable energy increasingly powers these operations. Solar panels on factory roofs generate 40% of necessary electricity, while heat recovery systems from furnaces warm offices and administrative areas. Some factories have already achieved carbon neutrality. Pen recycling programs collect used products directly from schools and offices. Automated separation technologies disassemble used pens, recovering plastic, metal, and ink for reprocessing. Each recycled pen prevents the production of 15 grams of virgin plastic. Packaging optimization reduced packaging material by 70% through intelligent design. Boxes are made with 100% recycled cardboard, using water-based inks. Algorithms calculate optimal packaging configurations, maximizing pens per container and reducing transportation carbon footprint. Ecological inks eliminated toxic solvents, replacing them with water-based compounds. New organic pigments maintain color quality while reducing toxicity by 90%. Ink waste is processed in bioreactors, transforming into organic fertilizers. The pen industry's biggest nightmare has a name: ball clogging. Microscopic dust particles or paper fibers can block ink flow, instantly rendering the pen useless. The solution came through nanometric filters that remove particles 1,000 times smaller than a hair strand from ink before filling. Temperature variations during transport created another complex challenge. Pens exposed to extreme heat leaked, while intense cold made ink thicken. Engineers developed thermoadaptive inks that maintain constant viscosity between 20 degrees and plus 160 degrees, using additives that behave like molecular thermostats. Extreme miniaturization of components represented a fascinating engineering problem. 0.7 mm spheres required manufacturing tolerances smaller than bacteria. The revolutionary solution was developing atomic precision machines that use electron beams to polish surfaces to absolute perfection. Production line synchronization almost made total automation unviable. With 47 workstations operating simultaneously, a millisecond delay at any point created catastrophic domino effects. Quantum control systems now coordinate operations with nanosecond temporal precision. The most recent challenge is mass customization. Consumers want unique pens, but mass production requires standardization. Integrated 3D printing allows personalizing individual components without stopping the main line, creating millions of variations from the same technological base. Quality control at extreme speed seemed impossible when production reached 50,000 units per hour. Quantum artificial intelligence now processes inspection data at speeds that surpass human capacity by millions of times, ensuring perfect quality even in ultra-fast production. The ballpoint pen has transcended its original function, becoming a universal tool that shapes our civilization. Billion-dollar contracts are signed with pens costing pennies, each signature representing decisions affecting millions of lives. The ink flowing from these pens carries the weight of international agreements, corporate mergers, and peace treaties. In operating rooms, special pens with sterile ink mark incision points in life-saving procedures. Surgeons trust the absolute precision of these markings, where a millimeter difference can mean success or tragedy. Each medical pen undergoes gamma sterilization and biocompatibility testing. Students worldwide write their futures with ballpoint pens. College entrance exams, doctoral dissertations, first love letters, billions of crucial moments in humanity are recorded through the simple but perfect technology of a rolling sphere on paper. Contemporary artists have rediscovered the ballpoint pen as a medium of expression. Artworks sold for millions of dollars are created exclusively with common pens, proving that genius transcends tool sophistication. Museums preserve drawings made with pens anyone can buy. Astronauts on the International Space Station depend on special pens that work in zero gravity. Modifications in internal pressure and ink composition allow writing in any orientation, recording scientific discoveries that expand the frontiers of human knowledge. Democratic voting systems use pens with special inks that cannot be erased or altered, protecting election integrity. Each marked vote represents a citizen's voice, transforming individual decisions into social changes through a simple mark on paper. The future of pen manufacturing is being rewritten by technologies that seemed impossible a decade ago. Smart nanomaterials promise to create pens that change color based on ambient temperature, or that write with inks that disappear after program time, perfect for temporary documents or secret messages. Molecular printing is emerging as the next frontier. Machines capable of arranging individual atoms will create components with properties impossible today: spheres that never wear out, inks that glow in the dark, tubes stronger than steel but flexible like rubber. Connected pens will integrate microscopic IoT sensors, transmitting data about usage, location, and even user handwriting analysis. Artificial intelligence will analyze writing patterns to detect neurological diseases early, transforming pens into preventive medical devices. Space manufacturing will enable producing pens in zero gravity, creating components with crystalline structures impossible on Earth. Orbital factories will use space vacuum to create ultra-pure inks and metals with extraordinary properties. Biotechnology will revolutionize materials. Plastics grown by genetically modified bacteria, inks produced by algae, components that self-repair when damaged. The frontier between biology and manufacturing is disappearing. Quantum automation will enable factories that instantly reconfigure to produce completely different products. A line producing blue pens in the morning could manufacture red markers in the afternoon, without human intervention or setup time. Radical sustainability will create 100% biodegradable pens that decompose in home composting, but maintain durability during use. Programmed life cycles will enable products that last exactly the necessary time. No more, no less. The journey of billions of ballpoint pens being born in automated factories reveals one of the most underestimated achievements of modern engineering. From plastic granules being melted to perfect pens emerging from production lines, we witness a technological ballet where simplicity and complexity dance in perfect harmony. 20 billion pens produced annually represent more than numbers. They're testimony to a silent revolution that democratized writing. Each pen costing pennies incorporates decades of innovation, millions of dollars in research, and technologies that rival the most sophisticated industries on the planet. The total automation behind this process, from atomic precision robots to predictive artificial intelligence, from computer vision systems to quantum control, demonstrates how modern manufacturing has transcended human limitations. Machines operating with precision impossible for human hands, systems thinking faster than human brains, processes that continuously optimize themselves. Absolute quality emerges from this technological complexity. Pens that write for kilometers without failing aren't accidents of nature, but products of meticulous engineering. Each test, each inspection, each control parameter ensures that something apparently simple is, in fact, extraordinarily reliable. The social impact transcends the factory. Ballpoint pens democratized writing, making it accessible to billions of people. Contracts signed, exams taken, letters written, art created. Modern civilization flows through the ink emerging from these automated factories. This is the story of how humanity transformed a simple idea into an industry operating at the frontier of technology. Pen manufacturing is not just an industrial process. It's a symphony of precision, proof that perfection can be achieved on a massive scale. Testimony that even the humblest objects can incorporate the highest technology. Now that you've discovered the secrets behind the birth of billions of ballpoint pens, one question remains. How will you see this common object with new eyes? The next time you pick up a ballpoint pen, remember you're holding the result of one of the most sophisticated manufacturing operations on the planet. Each component passed through dozens of tests. Each production movement was calculated with atomic precision. Each second of the process was optimized by artificial intelligence. Share this revelation with colleagues, friends, and family. Show them that apparently simple objects can hide extraordinary complexity. Let them discover that the 50-cent pen in their hands incorporates more technology than cars from past decades. Tell us your experience. What was the most surprising moment of this journey? Did you imagine pen manufacturing involved robots, artificial intelligence, and quantum control? What other simple products would you like to see unveiled with this level of detail? Challenge your perception about modern manufacturing. How many other objects in your daily life were born from equally fascinating processes? Your toothbrush, your paperclip, your eraser, each one may hide an extraordinary technological story. value the engineering behind everyday objects. Engineers, scientists, and technicians dedicated entire careers so you can write without thinking about the complexity behind this simple act. Each pen is a tribute to human genius applied to the service of practicality. The automated manufacturing revolution continues, creating technological marvels disguised as common objects. You are now part of this discovery. Spread the knowledge and help others see the extraordinary engineering that surrounds us daily. Special thanks to the leading companies in the ballpoint pen industry that opened their doors, metaphorically, to reveal the secrets behind this extraordinary technology. To the teams of automation engineers, materials specialists, and precision technicians who dedicate their lives to perfecting processes that make writing accessible to billions of people. Deep gratitude to industrial automation pioneers, visionaries who imagined factories operating without human intervention, and scientists who transformed science fiction into operational reality. Your contributions made it possible to produce billions of perfect products at costs that democratize access to technology. Special recognition to artificial intelligence developers, robotics engineers, and quality control specialists who elevated pen manufacturing to the level of technological art. Each algorithm, each sensor, each control system represents years of research and development. Tribute to the workers who designed, built, and maintain these marvels of modern engineering. Although factories are automated, brilliant human minds created each system, programmed each robot, and continue innovating to make the impossible routine. And, primarily, gratitude to you for dedicating your time to understanding the complexity and beauty behind processes that normally remain invisible. Your curiosity fuels our passion for unveiling the secrets of the factory-made world. Research and narrative. Factory-made team technical consulting. Industrial automation and precision engineering specialists. Scientific review. Materials technology and quality control laboratories. Continue exploring with us the mysteries of modern manufacturing. The world is full of extraordinary processes disguised as common objects waiting to be discovered. This documentary in narrative format reveals only a fraction of the technological wonders that surround us daily. The next time you write with a ballpoint pen, remember, you're using one of the most impressive achievements of modern industrial automation.